Having looked at how to solve logarithmic equations, let's turn to solve exponential equations. So, many of the same techniques work, converting exponentials to logarithms using a one-to-one property, in either case the one-to-one property of exponentials or logarithms, or we can also use the change of base formula. So here we have 5 to the 6x, and we have that's equal to 1 over 25. Now notice we have a base 5 on the left, and 25 can be written so we have base 5. So let's go ahead and rewrite that base on the right hand side. So we have 5 to the 6x, and 25 is 5 squared. Now we know that that is the same thing as 5 to the negative second on the right because it's in the denominator. Now we can apply the one-to-one property. So 6x must equal negative 2, and so x would equal negative 1/3. Let's go ahead and try this one. What's different about this problem? On the left we have base 3. And 17, however, cannot be written nicely so that we have base 3. So the one-to-one property of exponentials isn't going to help us here. So what we could do is we could go ahead and take the natural log of both sides. So we have natural log of 3 to the 4x equals the natural log of 17. Now we can take that 4x and bring it in front. Now, why could we take the natural log of both sides? Because the natural log and exponentials are both one-to-one functions. Now, we can divide both sides by 4 and the natural log of 3. That would make the 4 cancel and the natural log of 3 cancel. So on the left-hand side, we are left with just x. And on the right-hand side, we have the natural log of 17 over 4 times the natural log of 3. Now, an alternative is if we go ahead and convert this to a logarithm. So log base 3 of 17 would equal 4x. So that would be log base 3 of 17 over 4 equals x. But the trouble we run into, not that this is wrong in any stretch of the imagination, log base 3 of 17 is base 3, which our calculator will not do. So we can do the change of base formula, which takes us back here. So through just the change of base formula, we get back to the answer that we obtained here. So this is your answer. If you wanted to approximate that, you would have to put it in the calculator. And if you put that in the calculator, just make sure that you put parentheses around that whole denominator. If you want to practice putting that into your calculator, you should get about 0.6447. Now, let's look at this one. Here we have two exponentials, but they don't have the same base. So we cannot use the one-to-one property of exponentials. So let's again try taking the natural log of both sides. So we can take the 1 minus x, which is the exponent, and we can bring it out front. Now, if we do that, that's the entire exponent, so it needs to be in parentheses. So we have the quantity 1 minus x times the natural log of 3 equals, and now we can do the same thing with the 2x. It can come out front. So we have 2x, natural log of 8. Now we will take the natural log of 3 and distribute it. So we have natural log of 3 minus x times the natural log of 3 equals 2x natural log of 8. Let's get the x's on one side. So let's add x natural log of 3 plus x natural log of 3. So we have the natural log of 3 left on the left-hand side. Then on the right we have 2x natural log of 8 plus x natural log of 3. Now you'll notice that x is in two terms on the right-hand side, so we can factor it out. So we have the natural log of 3 equals x times 2 natural log of 8 plus the natural log of 3. And so if we divide both sides by 2 natural log of 8 plus the natural log of 3, we get our answer. So x equals the natural log of 3 over 2 natural log of 8 plus the natural log of 3. Now, if you want to approximate that, which we're not told to do, you would need to put parentheses around that entire denominator again, just to be sure. So you should, if you were to approximate this in your calculator, get about 0.20896. So here we have a different type of equation. Now if we're to solve this, this almost feels like a polynomial. And in fact, remember that a to the m raised to the n is a to the mn, which you might be wondering why I'm doing that. Well, if we have exponents that are multiplied, we can rewrite it like this. So 2x, those are multiplied, we can rewrite that as e to the x, which would be squared, minus 5 e to the x minus 6 equals 0. So this is a quadratic form. Let's let u equal e to the x. And our equation would become u squared minus 5u minus 6 equals 0, which factors into u minus 6, u plus 1 equals 0, which would mean that u equals 6 or u equals negative 1. But what is u? U is e to the x. So we have e to the x equals 6 or e to the x equals negative 1. If we convert this to a logarithm, we will obtain log base e of 6 equals x. But that means log base e of 6, we would not say that, we would say natural log. So x would equal natural log of 6. Likewise, this would be log base e of negative 1 equals x. But it does not make sense to take a log of a negative number. So we can stop there. Our answer is just natural log of 6.